Hey guys, this is yet another tool for the big project where I want to create a room with these HDAs. And this time around, this is a bookshelf generator. This is a bookshelf modeling part. This is book placement and randomization. If something will be confusing, try to rewatch it one more time. And if something will be still confusing, please write a comment in the comment section and I will reply to you and clarify things as much as possible. So let's begin. Let's start with the bookshelf, horizontal planks. So it starts with a simple line. I have a few presets to control, to give an option to scale the line proportionally. So for example, because by default it will be like so. Let me show you. So as you can see, as I scale in it, it scales only in one direction, while I want to scale it in both directions. So here's a, so you can copy this values and paste it. And save it as a preset. So basically, I'm copying parameter from the length and pasting relative reference here and multiplying and negating 0.5. And this is what it results into. And this width has been controlled inside of HDA itself. Let me show you, let me hide books. And this is the showed width. And this is what it controls. Oh yeah, let's dive in. So, as I said, it's a simple line. Then I'm doing a sweep to create a boxy looking shape. The only thing I changed is the surface shape. I changed it to square tube, and you can play around with the width. Then I'm doing a transform node, transform SOP, adding it. And here I basically modifying the thickness of the plank. And then I'm grouping it, grouping of the points to create a breakup of the silhouette. This is an option I have added to enable or disable stylized look. This is how I call it, at least. Basically what it does is break up the shape, break up the silhouette of the whole shape. So this is with it and this is without. Just add some variation of to the planks and to the, as you can see here, like this line is not very straight. Hope it makes sense. So yeah. And then here I'm using switch SOP, which is basically being used via this toggle. So I created this toggle parameter and then I copy parameter and paste relative reference here. Then I'm grouping a top face plank. This will be used later downstream. I will show you. But basically, this top face will be used to place books onto. Yeah, and the way I have selected this group is by disabling base group. Under the key binomial, so I have enabled this option. And I specify direction by 1, which means a positive y direction. And you can play around with the angle, because by default it will select everything. I have chosen value as 70 to only include the top face. And then I'm copying the planks onto the points. And this point comes from this another line, which is again, I have used this proportional preset. And the length is being controlled by the controller, which is basically controls the length of the whole shelf. And the reason I have used it is just basically for UI understanding only, meaning if I want to place 3 planks will be placed, but in reality, with this setup, I need 7 points. And the reason I need 7 points is because here I have used a group by range SOP, which selects every other point, and it doesn't select top and bottom point. So, which you can see here. So it selects every other point without top and bottom points. And if I want to do the reverse, to select only bottom and top point. This is how I will do it. And I can also do an offset here, as you can see. So just a matter of playing with these parameters. And before that, I have placed the line on top of the origin grid. And after that, I'm creating a bookshelf width. And here I have used a channel expression from the width, width parameter from the line, the copy parameter, paste relative reference, and then I'm dividing it by 2, because without dividing it, it will be much larger as I need it. But if I divide it by 2, and if I preview it, it will be adjusted there, just where I need. So I'm not sure if you can see it, but here is basically the width line. And here's the vertical line, and this will control the width of the shelf. And then I'm doing another sweep, which will control the vertical plank. And then I'm doing, and everything here is, by the way, by default almost. I have also set surface shape to tube and play around with the width. And after that, I'm transforming it a bit to give it some thickness or depth. I'm not sure. And this is an expression from here. As you can see here. And this expression comes from horizontal plank's thickness and Z. And this is from this plank. Basically to give a proportional look. And after that I'm mirroring this plank. I'm also adding a null to later reference it. And here I also grouping points to add a point jitter. And I'm deforming these points a little bit, just to add some slight stylized look to break up the silhouette. And this channel reference is from the HDA parameters. And here I also have a switch node to enable and disable stylized look. And then I'm merging everything together. And I have also merged the back plank. And the way I have done it is by using a simple grid. I'm extruding it. Outputting, also you need to check the output back option. Here's the distance. And transforming it a bit, scaling it down. And the way I have scaled it down is by referencing this output plank, auto vertical plank null. And the reason I need it is because I want to select a bounding box of these planks. Let me actually template it. I have scaled down this grid to match bounding box with these vertical lines. By bounding box, I mean something like this is their bounding box, but a lot more straighter. So I want the grid to be inside of this red box, basically. And the one way to do it is by using a bbox expression, and you have to specify an object which you want to get bounding box from. In this case, it's a null object. It's a null node with vertical planks, and I want to scale x-axis. So I have used a dx size expression. I'm not sure why it is how it is, but you can check out documentation if you want to understand it more. And the same goes for the y, but instead of x size, here I have a y size. And here I have also done a transform onto the z axis by doing a d z min, and also referencing vertical planks, because by default this grid plank, as I call it, at the center origin, and I want to move it back, basically, into this direction. And this is what this expression does. And if I want to do the reverse and to place this grid on the front of these planks, horizontal planks, I need to change this from z min to z max. And this will do the opposite. And then I'm copying this grid onto the bounding box. And the way I have done it is by using an object merge to reference this object. And I have specified a null here also. And then I'm extracting centroid. It will give me a single point of this bounding box. And you need to change, by default, it will run over primitives, or over pieces. And you can change to primitives, or in this case, I have changed it to detail. And then I can use copy to points to copy this grid onto this point. And then I have also used a switch SOP to add a stylized look as well. And then I'm grouping this black blank, as I will use it later. And then I use another switch to enable shelf back blank or disable it. And then I'm grouping everything together. So as you can see, I can change, enable or disable it. And the same goes for the stylized look. And after that, I'm doing a blast, and this is to place books onto. And and the reason I have used blast, no SOP, is because I want to separate only this primitive and don't use the other parts of the vertical plank. And then I'm also adding a null, just to reference it later. And then I'm grouping shelf. I will use it right now under the volume modeling, just to keep it organized for myself, I guess. But basically I have referenced this group just to make sure that the remeshgrid will do its thing over this group, over this specific group. And the remeshgrid, it's basically volume modeling. And if you don't know anything about volume modeling, I recommend you to watch at least a few videos to just get an idea what it is, because here I won't be explaining it too much. And the remeshgrid is basically a combination of VDBs. It's a LABS tool. Here I can play around with the sliders. I can get this type of look if I really want to, and it will work just fine. So we can do all sorts of crazy things, actually. So here, division size is basically how much of the details you want. The higher the value, the lower the resolution will be. It's kind of sounds counterintuitive, but it is how it is. So if you want to add more details, you need to lower the value, as you can see here. And adaptivity is basically to remove points. So if it will be set to 0, this is how it will look like. And you can either project or don't project original. And you can also do here smooth iterations. And yeah, you just have to play around with the sliders in order to get the better idea of how this node works. And after that, I'm using a LABS tool, another LABS tool. It's a remesher, which, as far as I remember, used inside of ZBrush. And the switch node is basically to enable, disable it. Pay attention to the topology. So unfortunately, I can't show you right now because I need to upgrade my license. But yeah, you can. The topology will look much better with this quad remesher enabled. And after that, I'm transferring a group from. I'm transferring this group shelf group again, because after volume modeling, all the groups disappear, and I need this group again. So as you can see, group shelf and top face plank is gone here. It's not present. And the reason I have done it is because I will use it later downstream to specifically reduce polygons on the shelf and specifically reduce polygons on onto the books, and some additional things that needs to be done only on the shelf geometry itself, like for example UVs and stuff like that. So here I have another switch to enable disable UVs, and I'm using a LABS auto UV. This is how it looks like. It's this huge because I have also added a UV texel density option. So this is how it looks like without enabling UV texel density. And this is with it. I won't be explaining what text intensity is. There are a lot of topics about it. Just Google it and read about it. It will be much simpler to understand than me trying to explain it. So yeah, here's how you can compute UVs. It's not ideal at the moment because I'm looking for a better way to do it. And then I'm creating a Unreal material. And I'm referencing a material, this material, which I can use later inside of Unreal Engine using Houdini Engine by drag and dropping a material path from inside Unreal from the content browser, and this node graph will pick it automatically. And after that, I'm merging shelf with the box, and the box is hidden right now. And if I enable box, it will look something like this. And the reason it takes so long because I forgot to disable enable UVs and computing UVs for books also. And let me actually enable texel density to show this difference. So right now, as you can see, the difference in UVs resolution texel density is very different. And if I enable LABS texel density, it will look something like this. So the texel density is much better right now. It's pretty similar. So I'm still exploring it. And this is how I've done it right now. So as you remember, I have this books placement null node, which I have used with this object merge. Then I'm creating it for each connected piece. So I want to iterate over this plank, and this plank. And this is why I have used this for each loop. And under the for each begin, you can as a method is extract pieces of points, and then you need to enable create meta import node, and I will be reference it a few times or 2 times exactly. Then I'm scaling this plank down. This is basically to like give a better placement for the books, because if I won't do it, the books will be inside of the vertical plank as well, intersecting with this geometry. And then I'm extracting centroid from this face plank. And the reason I need it is because I want to place this line with all of these points, and these points this points is basically determines the number of books. And here I have also used a line with again this expression. Then I'm using a group arrange to deselect last points. And then I'm copying it onto this plank. Then I'm doing a sort. And this is where randomization starts to begin. So as you can see, without sort SOP, and by the way, the sort SOP, here's the options. Under the points, I have set point sort to shift, just to shift points. And if I enable it, so as you can see, here is a first 0 point number, 1, 2, 3, 4, 5, and so on. And if I enable it, the point order has been changed, and now 0 is here. And the way I have done an offset is by using a detail expression, basically to access iteration number under this for each loop. here you can see the detail attribute, and it's called iteration. And here I'm referencing it. So I'm accessing for each loop, like I'm specifying the for each loop under the detail. I'm specifying what attribute I want to extract, iteration in this case, and 0, I guess, as far as I remember, is the default value. And I want to multiply whatever value will be returned here by the specified seed I have here. Seed is an additional parameter I have added to this node. So here I have a 32 seed. Basically, a bit of different value will be instead of the like actual iteration number value. And here is this description if you want to understand it better, if it makes sense. And the way I have added the seed option is by edit parameter interface, integer, oops, and that's it. And then copy parameter, and after multiplication, place relative reference. And then I'm doing a books. Let me actually show you much better this books itself. Right now it doesn't look. Let me actually show it that. If I will sort books, so this is what it does basically to give a bit understanding on why I have used it. So it just shifts points onto which books has been placed. And the same goes for the normals. I have changed the distribution to this direction and orientation, and the direction is set to 1, and the cone angle is being controlled by the HDA parameter. It's basically interesting why it's not changing. Oh, it's a minor one. Just add a little bit of randomization. So here's without it, and here's with it, just to add some minor breakup. And the global seed has been controlled by the HDA parameter as well. And the book's geometry comes from an HDA I have created. And I will leave a link in the description about me doing a breakdown of this HDA. And then here I have done a book rotation. And then I'm using a boolean to shapes, because by default it comes from this HDA paper part, and book cover is a separate geometry. And then I'm copying books onto these points, and then I'm iterating over each book with for each connected piece here as well. And the reason I need it is because I want to randomize individual book scale. And the way I have done scaling is a bit of it might be confusing a little bit. I'm accessing for each loop metadata node. In this case, it's a different one. This one, I'm accessing iteration number. I'm adding a seed value from the seed parameter. This one, and I'm randomizing this value, and I'm fitting it between 0 and 1. And this is a minimum and maximum value. And the similar setup goes here. But here I'm also dividing it. Here is like so. And here is like so. And one thing to keep in mind is that this book is not centered onto the world origin. And we need to make sure that the book will be rotating its local axis. Because if I disable it, and if I rotate it, it will be rotating around the world origin, and we want to do the opposite, to rotate it around its own axis. And this is the expression to do it. And you can have a look on the documentation to get a better understanding of what. And I'm using a seed just to randomize scaling and stuff like that. And here is also another thing, and what it does is just to rotate books 190 degrees to like rotate from the back to the front. And the expression for this is like so. So here I'm using an if statement. It checks for each metadata iteration number, and so it does a model operation onto this random seed value and the threshold. And whenever this is equal to 0, I want the book to be rotated. Otherwise, don't rotate the book. It kind of sounds confusing, but essentially what it does, so as you can see with this toggle, I can rotate books. So I can rotate front into the back, if it makes sense. And with this threshold and a random seed slider, I can add more books. And it's not perfect, by the way, so I'm still exploring how to do it better. But yeah, this is what it does, essentially. And the switch node is to enable, disable this option. And after that, I'm using the match size again. Basically, it will place books onto the, it will justify y by min and place books onto the horizontal plank, which I have here. And then I'm creating an attribute, ID attribute, using the attribute create SOP. And I have also used here an expression to extract the iteration number from the for each metadata. And this ID attribute will be used here in this attribute wrangle. And what this wrangle does, in the most basic term, is that it creates 5 primitive groups, like for example like so, and it adds a random book onto the inside random group. So here I specify the groups, number of groups I want to create. In this case it's 5. And after that I'm creating a group ID number. So it takes a random from the ID attribute, which I have created here using this attribute create. And then it multiplies by number of groups. And it converts everything into an integer. And the +1 is used to include the last number of the group, meaning if I want to create 5 groups, without this +1, there will be 4 groups created, but +1 creates the last group as well. I'm not sure how to explain it properly. And then I'm creating a group name, using sprintf function. And this will be a group name, and the %d stands for a digit, as far as I remember. And then a second argument will be the group ID integer. And this is basically a placeholder for this value. So it will become like so. And sprintf is basically similar to printf, but sprintf will return a string value instead of just printing the value. This is the main difference as far as I remember. And the last part is to create a primitive group. 0 is the first input that comes to the attribute wrangle. Then I'm specifying a group name, current primitive number. In this case, it will be a book, the whole book. And 1 is to add to the group. 0 means to exclude from the group, and 1 means to add to the group, but double check in the documentation. And that's pretty much what this wrangle does. And downstream, this wrangle will be used to create Unreal materials, to assign, to group randomly, to create 5 groups with random books without repetition, which will be used to assign materials, to assign Unreal materials later. And the name SOP is to create a USD path, which I haven't used actually. It will be disabled. Then another switch SOP to enable disable UVs. And this is the end of the inner. And this is the end of the inside for loop. And then I'm doing another match size, which places books onto the bounding box of the blank I have as an input, which is this one. And inside this match size SOP, I have used, and I'm referencing a top 5 plan group, expanded group. And here are my settings. And after that, I'm blasting all of the groups of the books with a separate group from 1 to 5. And then I'm assigning Unreal material, which is this one from 1 to 5. And later inside of Unreal, I can like replace this value with a material or instance path, like drag and drop. And then I'm merging everything together. And this is the end of the full loop. So here is a shift randomization. Here's a book scale randomization. Here's a book random rotation. Book height. Book thickness. Number of books. And after that, I'm creating a group called group books, and then using switch stop, another to display or hide books. And here as switch requires a second input, so it can be like so, it will give a warning. So whenever I'm clicking hide books, it will switch to this null object which doesn't return anything. And then I'm merging everything together. I'm scaling it up a little bit. I'm creating another null object, which I will be used later using band SOP as a bounding box object. And then I'm either using Texel density SOP or not. And then I'm doing a UV layout and enabling or disabling a Texel density checker. And then I'm doing a band. Actually, disable this. So this band. So just to create this type of effect. And under the band, I have changed the up vector to 1, and you can change it basically here, and all of the settings also. The only thing I have changed here is this capture direction and capture length options. Here I have also used the bounding box expression to get the bounding box of this scaled shelf, no matter its height or width. It will always match the bounding box of it. And the reason I want it is because I actually want to get the capture length, correct capture length for the band SOP to function, for the band SOP to work properly. Because otherwise, for example, if I change it to default value, it will be like so. It kind of works still. So this is a difference with default and custom value using bounding box for the shelf. And then I'm using a switch SOP to enable disable bending. And after that, I'm exporting high poly and low poly. So I'm subdividing the mesh. I'm creating normals for the shelf itself, for the books. This switch SOP is basically when the box is hidden. So everything, so normals computes as expected. Then I'm cleaning up low high poly mesh. I'm only keeping normals, book attribute, UVs, and Unreal material attribute, as well as a few groups. and this group is for Unreal Engine collision detection. And the same thing goes for the low poly, but here I'm just poly reducing it with the preserve quads option checked on, and I'm specifying group where I want to poly reduce polygons. And this expression and this channel reference comes from this HDA and this HDA parameter. So I can control the number of polygons the percentage of the polygons to keep. Then I'm computing normals. Then I'm reducing polygons for the books. Computing normals. Same thing here with the switch. Cleaning everything. And also exporting the collision group. And let me actually show you how it would look inside of Unreal. So here I'm inside of Unreal. I have 5 instances, 1 material and 5 book instances. I have a bookshelf material and the instance here as well. Here's my HDA, which is this one. And let me actually show you about color material randomization. So here I have 5 materials of book materials. And what I need to do is just to drag and drop material here. As you can see, it's cooking right now. So only on these books material has been applied. And I can do the same thing to this group. And here it could be a lot more groups to give a lot more variations. And let's apply a final one, like this one maybe. Oops, not there. Wrong. And to enable, for example, back shelf, I have to just enable it, this option. And here you have it. And stylized look also with a single checkbox. Bend deformation. And now you can control it. Possibly like so. Maybe a different vector. Yeah, like so. And I can also control the jitteriness of the horizontal plank. This one. And I can control the height of the bookshelf. And all of the other parameters basically. The last group I have created for the collision, Unreal collision. This is what it does. So collision works perfectly. And if we preview it. So hope you found it useful, hope it wasn't too confusing, and if it was confusing, as I always said, please write a comment in the comment section and I will answer your question. And see you in the next video. Take care. Bye.